Hi, my name is Josh Joseph, and this is my Physics 2211 Lab 3 report. Here's the introduction, and in this lab we had two different parts. Part 1 was determining the mass of the black hole, and Part 2 was determining the velocity of the ship to fly near the black hole and leave the system without crashing. And the summary results is that we determined the mass of the black hole was around 1.1098 e 34 e to the power 34 kilograms. And the velocity of the ship to escape around velocity of the ship to escape the system was around negative 3.5 e7 and 4.5 e6 meters over second in the x and y position respectively. So for both parts, we're using the same formulas. And in this case, we're looking at Newton's second law, which states that F net is equal to dp over dt, and that F net is also can be broken down into two different components: F net parallel and F net perpendicular. And we're also dealing with gravitational force. F grav equals g gravitational constant times m1 times m2 over r squared times rh. Now, one thing to keep in mind is that we did say that F net is equal to dp over dt. And since we're assuming that gravity is really the only force applicable in the situation, we can replace F grav with dp over dt and then isolate for M2 to determine the mass of the black hole, which we're going to be using in the code form. So when we quickly look at that, we can see right here there's the gravitational constant that we're using, the mass of the star, and also the number of seconds in a day. Now, as we continue through the while loop, we can see that the different components that we accounted for. So in this first part, right here, we're dealing with initial and the final velocity. The second part, we're integrating momentum by doing mass times velocity for the initial and final velocity. And then we're also determining delta v over delta t in this situation, and we're also setting the dp over dt of uh, uh, variable. And we also, as we said before, we're assuming dp over dt is equal to F net because that's like Newton's second law. And then the second part, we are finding the parallel change in P and then setting that. And then we're also calculating dp over dt perpendicular and then setting that variable over here. And then after collecting all the components, we're using the formula that we use to isolate to get the mass of MBH, then print out that value. And then this next component is just the arrows associated with the parallel and perpendicular forces acting on the ball. So when we run this program, we can see as the ball continues, we can see the arrow, the parallel and perpendicular forces change as the ball rotates around the black hole. As we can see at the bottom, the average, like the mass of the black hole estimated based on different situations. And then we also have the F net perpendicular, F net parallel forces attributed to us. Now let's look at part two of the situation. In part two of the situation, we're trying to determine the velocity of the ship just in order to escape the system by passing through the black hole. And in here, we're using the mass of the black hole that we determined from part one. Here are the constants that were given. And then for the speed, ship, and x and y direction, we did a trial and error to determine those speeds. Now, as we scroll through, we can see the multiple forces acting on the in this whole overall system, which is going to be F grav on the planet from the black hole, F gravity from the of the planet by the ship, the net force on the planet, then F grav on the ship by the black hole, F grav on the ship by planet, the net force on the ship, and then we account for that by adding all those forces all together, and then we use this to determine the momentum, which is force over time times delta t. And then when we run this program, we'll get something just like this. So, discussion questions. First one will ask us what does it mean, and basically determine the differences between the parallel and perpendicular forces. And since we're measuring and we measure for dp, we assume that net forces were equal, and so because of that, we were able to deduce F net from there. And then the next situation, the what if scenario, is what if we wanted the ship not escape the system, but rather just orbit around the black hole? Through trial and error, we were able to determine that the ship's speed in the x and y direction would have to be negative 8 e to the power 5 and 1 e to the power 7, both in their retrospect. In conclusion, we determined the mass of the black hole using gravitational formula and Newton's second law, and using this mass determined velocity for the ship in order to pass by the black hole and escape the system. Thank you.